Hello everyone, this is Steve. Thanks for joining me. If I want to graph this exponential function f of x and this logarithmic function r of x, then I should start by finding some ordered pairs on the original exponential 3 to the x and its inverse log base 3 of x. So let's get started with that. So if y equals 3 to the x, then we get three key ordered pairs on that, which are just going to be negative 1, 0, 1, starting with the x's, and then the y's will be 1/3, 1, 3. Then the logarithm graph, which is the inverse of that, log base 3 of x, will have the exact same ordered pairs but swapped. So 1/3, negative 1, 1, 0, and 3, 1. All right, that allows us to come up with some ordered pairs that are on these two functions. So we're going to do that next. Now there's a couple things going on here. We have this minus sign in front, which is going to make all the y values negative. And then because of this plus 4, we're going to add 4 to them after we make them negative. So we're not actually going to change the x values at all. So those are just going to stay as negative 1, 0, and 1. But every y value, you first make it negative, then add 4. So if we make 1/3 negative and then add 4, we get 3 2/3. If we make 1 negative, negative 1 add 4, we get 3. And if we make 3 negative, negative 3 and add 4, we get 1. So we get three ordered pairs on that graph. Over here, for r of x, we've got a couple things going on. We've got a negative sign out front, and we've got a plus 2 on the inside. So that plus 2 means we're going to subtract 2 from every x value, and the negative sign in front means we're going to change the sign on every y value. Make negatives positive, make positives negative. So I'm going to start by subtracting 2 from every x value. So that's going to make this negative 1 2/3. You can check that on a calculator if you want. This will become negative 1, and then 3 minus 2 is 1. Then we just change the sign on the y values, so the negative 1 becomes 1, the 0 doesn't change, and the 1 becomes negative 1. Now we can plot these points and figure out what the graph of this adjusted exponential and this adjusted logarithmic function looks like. All right, so we'll graph f of x first. I'm going to plot my three ordered pairs here, so negative 1, 3 2/3, right around there. 0, 3, right around there, and 1, 1, right around here. Now what happened, everyone, was the graph flipped over and shifted up 4 units. So what we actually have, everyone, is we now have a horizontal asymptote right here at y equals 4, and the graph looks like this. And even though we didn't get a specific ordered pairs down here, it does drop down like that forever because it's been flipped and shifted up. So while the domain is still negative infinity to infinity, it still goes left and right forever, the range on this is going to be negative infinity all the way up to 4, not including 4. So we use a parenthesis. So that's what the graph of f of x would look like, an adjusted 3 to the x function. We come over here to the logarithm graph. It's still going to be a logarithm graph, but it's been reflected and shifted. So let's see what kind of picture this gives us. So negative 1 2/3 and 1. So I get an ordered pair right around there. Negative 1, 0 right there. And 1, negative 1. So right there. So what happened here was the graph did flip over, and it also shifted to the left 2 units. So the vertical asymptote that used to be right on the y-axis is now right here at x equals negative 2, and the graph comes down like this. So while the range is still negative infinity to infinity, the domain on this has changed, and the domain on this graph is going to be negative 2, not including negative 2, all the way up to infinity. And it looks different than a normal logarithm graph for log base 3 of x because it's been reflected over and shifted. Okay, thanks for watching. I hope that helped.